Hello there and welcome to another session of the SRE Conference 2021. This is the first time I am enjoying this conference both as a speaker and attendee, and I gotta tell you, I am learning a lot. And I do hope that you are learning a lot too. If you are wondering if you are in the right track, in here we're gonna be talking about OpenTelemetry and how this cloud-native framework for observability can help you to build instrumentation in your applications to bring telemetry data such as traces, metrics, and logs into observability backends. My purpose with this talk is to give you a practical perspective of OpenTelemetry. So I'm going to explain the architecture, the current state of the framework, and I'm going to be showing you live examples of two microservices, one written in Java and another one written in Go, that were instrumented to send this data to a observability backend. For those of you that don't know me, my name is Ricardo Ferreira, and I'm a developer advocate with Elastic. At Elastic, I'm part of the developer relations team that focuses on dealing with the community members that are interfacing with the technologies provided by Elastic. Before Elastic, I used to work for other technology vendors such as Confluent, Oracle, and Red Hat. In the bottom of the slide, you can see my Twitter handle, so feel free to follow me there and start any conversation about whatever we're going to discuss in this talk, or the subjects that I like to discuss as well, such as distributed systems, observability, streaming systems, and databases. Without further ado, let's get to it. The agenda for today includes a brief discussion about observability, and then we're going to jump straight to the discussion about OpenTelemetry. After discussing OpenTelemetry, I'm going to show you how to create from scratch a observability backend. Then I'm going to show you a live example of a microservice written in Java that has been instrumented using OpenTelemetry to send data to this observability backend. Subsequently, I will show you another microservice, this one written in Go, that just like the one in Java has been instrumented using OpenTelemetry to send data to the observability backend. If you ask anyone these days about what is observability, there is a high probability that they will start their definition saying, yeah, observability is all about the three pillars, the traces, metrics, and logs. And fundamentally, they're not wrong. Like historically, observability evolved to this culture where we have a pillar dedicated to logs. For example, I'm using Elastic Stack for handling those, or another pillar to handle metric data or time series data such as Prometheus, for example, and perhaps another backend and set of tools, processes, and people focused on distributed tracing, perhaps using Jaeger, for example. The problem is, individually, they do not provide the actual value that observability is supposed to deliver, right? It's just like this very good analogy comparing tires, gasoline, and motor oil, and saying that they build up what we know as F1 tracing. So technically it's not wrong, but it's not just like that. What we actually need is to stop thinking about observability as silos of types of telemetry data and think about them as simply pipes, right? Different type of pipes that ultimately will send all of them to a common location that throughout the course of this talk we're going to be calling observability backend. And once those telemetry data get there, they're going to be integrated, correlated, and most importantly, they're going to give you the tools to ask any type of questions about your systems that are running in production. A very effective way to implement observability these days is using OpenTelemetry. OpenTelemetry came as a replacement to former technologies such as OpenTracing and OpenSenses. Individually, those technologies used to cover, for example, OpenTracing tracings and OpenSenses. They would be focused more on metrics, but like I mentioned before, individually they don't provide the value that we are trying to achieve with observability. OpenTelemetry comprises all the lessons learned and even some pieces of code that has been accumulated throughout the years, and now it builds up into a new project that is supported and maintained by CNCF, and it is free and open. So it has all the ingredients for you to start leveraging this type of technology. And most importantly, it has the sole objective to support all types of telemetry data, such as metrics, traces, and logs. One of the cool things about OpenTelemetry is that it provides a very vibrant community, and it's growing in a very fast pace. And I would highly encourage you to start being part of this community. OpenTelemetry has a set of topologies supported on this architecture. So let's start discussing about how you could start using observability. It would highly depend on the first fundamental question that you should ask for your environment. Is my observability backend compatible with the OpenTelemetry protocol? If the answer is yes, then your applications can start using the collectors or the agents that are provided by the OpenTelemetry architecture to send data directly to your observability backend. Because again, the observability backend do support the OpenTelemetry protocol. There are some observability backends out there that do not support the OpenTelemetry protocol, and that's okay, because for those scenarios, you can simply have your applications leveraging the agents to send data to an instance called collector. A collector is a component that is part of the OpenTelemetry project. This is not something that you have to write on your own. It's something that you simply grab the image, deploy it, and start using it right off the way, right? The role of the collector is to act as this mediation layer between your application and the observability backend. So in other words, it will handle the protocol transformation for you automatically. A very common question that people have these days regarding OpenTelemetry is that about being stable enough to be used in production. Like if you are thinking about starting a project today, you might be asking yourself, should I start using OpenTelemetry for my observability needs? Oh, but I have heard that it's not stable enough, or people should avoid using it until it becomes stable enough. So let's discuss this for a moment. First of all, you have to understand that OpenTelemetry is a project that comprises different types of telemetry data. Like I mentioned before, traces, logs, and metrics. In regard to traces, the specification is GA, so you are free, and like I would highly encourage you to start using the tracing capabilities from OpenTelemetry for this. And most of the programming languages are up to speed about the support for this. There might be some programming language whose support to OpenTelemetry is not very effective yet, but it is your job to discuss with the communities for each programming language about the future support for it, if you found that's not stable enough. And with regard to metrics, metrics are not GA, but the plan is to get GA this year. Last I heard was about end of November to be GA, and most of the programming languages are also up to speed regarding the implementation. So I would say it's safe for you to start leveraging. And even if you are in doubt if you should use it or not, there is the collector component that can mediate and alleviate a little bit of this uncertainty regarding the stability of the project. Regarding instrumentation libraries, what are instrumentation libraries? So maybe your application is leveraging a common technology such as Redis database or Elasticsearch. So you do want that the observability framework such as OpenTelemetry be able to instrument the invocations and interactions with those technologies automatically. So that's what we call instrumentation libraries. And depending on the programming language that you are using, the instrumentation library support is quite comprehensive. Ultimately, you can use the collector to handle the logs. And why I'm saying this, because logs is the only part of the OpenTelemetry project that is not ready yet, right? There's a lot of discussions, there's a lot of debates, there's a lot of possible scenarios to implement, but the reality is that the support's not there yet. So that's the only part of OpenTelemetry that I would agree with you and say, yeah, let's avoid it for a second. Unless you are a very courageous person and you want to start collecting logs using, for example, the collector that is capable of doing this. The collector can read the logs for different types of sources and then send to the observability backend. So that's an option for you. But overall, if we start thinking about observability, specifically in terms of traces and metrics, I would say go ahead and start using, because it is stable enough for you to avoid any surprises in production. Now let's start discussing some of the practical perspectives that I've referred before in the beginning of the presentation. So right now, what we are going to do is to create from scratch an observability backend that will store and hold all the telemetry data sent by the two microservices that will be instrumented using OpenTelemetry to send this data. For this demo, I'm going to use Elastic Observability as the observability backend. I think that Elastic Observability provides you a very good approach for you to handle all types of telemetry data because it is an observability solution that supports not only tracing, but also metrics and logs. So you have in one single solution everything you need to handle your observability projects. Let's create one observability backend using Elastic from scratch. Right now, I am logging into Elastic Cloud, which provides you a very quick and effortless way to spin up new environments with Elastic technologies. So I'm going to create a new deployment, and I'm going to call this deployment SREcon21. I'm going to change the provider to Google Cloud, and I am going to pick up the region North Virginia because it's close to where I am right now, which is North Carolina. I'm going to use the latest release available at the time of this talk, which is the 7.15 release. Usually, the APM and observability capabilities are enabled by default in any deployment that you created with Elastic Cloud, but it's always a good idea to make sure that they actually are. So if you click Advanced Settings and you scroll down a little bit, you're going to see a section that says, yeah, so APM and Fleet are enabled in your deployment. So I'm going to go ahead and click Create Deployment, and at this time, the Elastic Cloud solution is already creating my deployment. It's going to take up to 2 minutes. And meanwhile, we can start discussing the microservice written in Java. All the source code for this microservice written in Java is available on GitHub. So what we're going to do now is clone this GitHub repository over here and start playing with the code. So I'm going to start things off by cloning that repository here locally so we can start playing with the Java implementation. Now that the code has been cloned, I'm going to open up in my IDE. Now that we have the code cloned locally, let's make some changes so the Java microservice can start sending data to the Elastic Observability backend. So as you can see here, there are two Docker Compose files, one version for running with the collector and another one without the collector. For this demo, I'm going to use the version with the collector. So as you can see here, the Hello App application has been configured to send the data to this endpoint, which happens to be the collector. And the collector itself is coming from this Docker image, which is, as you can see here, is part of the OpenTelemetry project. So as I mentioned before, the collector is not something that you have to write code to it. The only thing you got to do is to provide a configuration file, which also to be in YAML as well. So this configuration file is very simple. The only thing you're going to see here is that it exposes some endpoint in the OTLP protocol, which is the OpenTelemetry protocol. And then any data received will be exported to also in OTLP to an endpoint. And specifically, we are going to change this endpoint to point to the Elastic Observability instance that we have running on Elastic Cloud. And since we are using HTTPS here, we are going to set this insecure to false. Also, we need to authenticate the collector with Elastic Observability. So what you can do about it is provide some headers, and in the headers, you are going to create this authorization entry here that contains a API key. So this API key here has been generated using on Elastic Cloud. You can easily go to the Kibana version and generate one for yourself. That is going to act as your bearer token during the communication. So I'm also going to remove all the Elastic Observability configuration that is supposed to run locally on your machine. Probably when you test this, you want to keep this because you're going to run everything local, but it's your choice. And I'm going to remove also the dependency on Elastic Observability. So now we have only the collector and the actual Java microservice in the configuration file. So with everything up and running, we can spin up those containers and start playing. So I'm going to use the run with the collector option, and then I'm going to start them up. So as I mentioned before, this code that we have here, why we are building the Docker container is building the code. The code that I have here is already on the GitHub, so you can spec the code, but pretty much what you're doing here, this is a Spring Boot application that essentially is using a Java agent to do the whole instrumentation. So how the Java agent is configured, if you look here on the Docker file of this image, you're going to see that the actual container is going to run a version of the Java agent from OpenTelemetry, and it's going to execute all the code using this agent. That's why in the actual code, you can simply in Java do what we call retrieve all the OpenTelemetry objects, right, that will be created automatically by the agent. So you don't have to manually instantiate them by yourself. When we see the code in Go, you're going to see how different this is, because in Java, you can simply retrieve them. So right here, I'm retrieving the tracer and the meter, and throughout the code, what I'm doing here is essentially using those tracers and meters to create my own spans in terms of tracing, and I'm also creating some metrics using the meter. So let's see if this is actually working. So apparently all the containers has been started. Let me just double check here in the logs of the collector if everything is up and running. So it seems to be, so everything is ready. So let's check now on Elastic Observability if the traces and metrics are there. So I'm going to go to Observability, and if I check the APM portion of it, I can see right off the bat that there is a microservice or Hello app in Java. And then if I inspect this Java microservice, I'm going to see that there's a transaction called /hello, which is exactly what the endpoint is being exposing. And I can clearly see all the details regarding this transaction, the latency, throughput, and failed transactions. Pretty much all the golden signals for any decent SRE discipline. And you can also see here the timeline of this transaction. So all the transactions that has been executed right now. So the Docker Compose periodically perform a call into the endpoint, and these are the calls that you are seeing here, right? So those are the traces. Now let's see if we have some metrics. I'm going to check on Discover to see if the documents with the actual metric. There's a bunch of them, but I'm going to filter the ones that has that custom metric that I've created before. I'm going to filter only for those. And as you can see here, there is a sample document that carries this information with the metric. And if you look closely, you're going to see that this is the metric that we've created programmatically. So we call it a custom metric, and this is the current count of the metric. So everything is running as expected. So now we can start seeing the equivalent of this, but now in Go. Now that you have seen a microservice written in Java using OpenTelemetry, let's see how that would look like for a microservice written in Go. That experience will be interesting because you're going to see the differences between the implementation, although the result will be the same. Just like the Java one, the source code of this microservice is available on GitHub. So let's clone that repository right now. Now, just like we did with the microservice written in Java, let's clone the repository that contains the source code of the microservice written in Go. So I'm going to clone the wrapper locally, just like we did before. And I'm going to open up the code in my IDE. All right, so let's try to do the same process we did for the Java microservice here on this Go microservice. So I'm going to start by changing the configuration from the collector to, like we did before, we're going to replace the endpoint to allow point to Elastic Observability on Elastic Cloud, and then check the insecure to false. And then we're going to actually add the header to the configuration so the collector can authenticate itself with Elastic Cloud. So now that we have everything up and running, I am going to also change the Docker file, Docker Compose file, to remove all the local Elastic Observability configuration, because we're going to be using the one running on Elastic Cloud, just like we did before, and then also remove the dependency on the Elastic Observability. So now we have only the collector, just like we did before, and the microservice, but this one is written in Go. I'm gonna start them up, and meanwhile that they're starting, I am going to actually run with the collector and up -d. I am going to explain what the code is and what is the biggest difference with what we have in Java. So if you look here on the Go code, albeit it's obviously written in Go, but the biggest difference from the Java microservice is that in Go, we don't have an agent, right? And what's the role of the agent? Is to automatically instrument the process that runs your application or the microservice to dynamically inject some objects. So we don't have this in Go, so what we can do is to use the OpenTelemetry API directly to instantiate everything we need to use, for example, to handle traces and metrics. So as you can see here, I am using the API to create a tracer exporter, and then I am registering the tracer provider by myself. This is exactly what the agent in Java did automatically. So in here, I'm using a programmatically approach. And then I'm using the same process for the metrics. I've created my own pusher, which is going to periodically push the metrics to the server. And then I am creating programmatically all my metrics over here, right? So the microservice seems to be up and running, just like we did before. Let's double check if the in the logs, if the collector is okay. It seems to be, right? Just like before. And now we can inspect in the observability backend if everything is in place. So now let's go back to the observability session and jump to the APM part. And now we can see here now that we have a different microservice, still name it Hello App, but the icon is different, saying that it's not longer in Java. The transaction continues to be /hello, right? As you can see here before. And then we can see that the transaction remain almost the same because I've tried to do the same traces and spans just like I did in Java, but you can see that visually is a little different, right? Most importantly, if you click in one of those spans over here and see the session metadata, you're going to see that the amount of details are different from the ones that you have in Java now. Now we are dealing with an agent from OpenTelemetry that is no longer Java, but now it is from the Go world. So you can inspect this by looking the details of this microservice over here. So as you can see here, we're using the framework for an OpenTelemetry for Go, right? And then the protocol is OTLP. That's the information that has been gathered automatically for you. So pretty much everything is in place. Let's double check also if we have some metrics coming in. So the metrics should be in place, just like we did before. And then let me refresh it and then filter only for the metric number, right? So yeah, so they're in place just like before, and we're good to go. And keep in mind that we have two metrics here. One is the cursor metrics, the number of execution, and we've created this metric programmatically in the code. So let me go back here in the code so I can see, you can see better. We've created here two metrics. This one called number of executions is a metric that's supposed to be incremented manually. What I mean by manually is that every time the actual microservice executes, which is in this function over here, I am going to manually increment that metric, right? So this is one way to go. The other way to go is to create what we call a automatic increment type of metrics. And in this version, this is an example that I've created here. I've created this int64 counter observer, right? And what an observer does, you provide to the code a callback function, right? So the metric systems or OpenTelemetry will periodically execute this code that you provided here, which is going to automatically update the value of the metric. So you don't need any external process or functions to actually update the metric for you. So this is coming handy for metrics that you know how to calculate them, but there are no dependencies on any other pieces of code. Pretty neat, huh? And keep in mind that this is also available in Java. The code is there. So pretty much what I've done here in Go, it is also available in Java. So feel free to inspect the code that is available on GitHub. If you want to play with the Java and Go microservice, sending data to a real Elastic Observability backend, just like I've shown here, you can very quickly create an Elastic Cloud account. Just follow the instructions of the link provided here. There is no requirement for credit cards, and you are free to experiment with the technology without any commitments. If you want to understand more about the work I do, feel free to reach out on Twitter, where you are welcome to follow me there. And I have a YouTube channel where most of the talks, demos, and workshops that I create and present are also available there. Alternatively, you can use this link here where you can find the slides of all the presentation that I provide in conferences and meetups. With that said, I would like to thank you for your time, and I do hope that you continue enjoying the awesome talks that are available in this conference. See you next year.